As David said, I'm Mike. I'm here to talk about AWS and Puppet. I know you're here to hear about fun stuff rather than my whole life story, so I'll get through the intro side pretty quickly. I'm a sysadmin with a passion for automation, so I'm a big fan of Puppet. I'm a Londoner based in Amsterdam, which might be why this talk starts at 4:20. I run Epitech. We're a technology consultancy in Amsterdam. We do cloud stuff, basically. For a while, I wasn't sure if I was a sysadmin who does development stuff for fun or a developer who likes doing sysadmin stuff. But then the whole DevOps thing exploded, and it doesn't really matter so much anymore. So today, I'm going to talk about a few parts of AWS. I just want to do a very quick run-through to make sure we're all on the same page. So could I get a quick show of hands, see who's already using AWS? All right. So like 4 people who aren't. Cool. So, OK, you're probably all going to know this anyway, so let me just rush through this very quickly. A couple of services I want to talk about. It's EC2, the Elastic Compute Cloud. So we have our on-demand instances of various sizes suitable for different workloads. Next, we have Amazon Machine Images, snapshots of machines, which we can use to launch as many instances as we want once we've taken a snapshot of a machine at a particular state. And finally, user data is a string which is passed to instances when they're launched and is then accessible to the instance when they're running. Another component is autoscaling. So Amazon has this really famous marketing diagram, which I couldn't find a copy of in time for the slides, showing how as demand goes up and down, your provisioned capacity can match that so you're not wasting any capacity. And autoscaling is how you do this. It lets you create groups of EC2 instances, and the number of instances in a group can scale up and down based on various metrics like CPU load or the number of tasks in a queue and so on. So this is the elastic bit of Elastic Compute Cloud. CloudFormation is my favorite part of AWS. For those that haven't used it, it lets you create a JSON file describing all of the components in your infrastructure. So you make what's known as a stack template, JSON file, upload it to CloudFormation via the web console, the API, or the command line tools, and then the resources you describe are automatically created by AWS. Oh, I think this is pretty cool, to say the least. And the first time I read about it, I sort of thought it was too good to be true. It wasn't quite going to work as described. So I was very happy when it did. So what Puppet does at the software and OS level, CloudFormation does with your AWS resources. Now, what you see here is a very basic stack template. If you upload this to CloudFormation, it will launch a single instance using that AMI and provide, allow you access with my SSH key. The problem this solves is without CloudFormation, there's no way to really track changes to your infrastructure in AWS. A lot of the stuff you do through the web console or the command line tools and so on. So to pick autoscaling as an example, there's no web GUI for autoscaling, unless Amazon have released it in the last couple of hours, which wouldn't actually surprise me. So the only way to modify autoscaling groups is with CloudFormation or with the command line tools or API. So on Monday, Alice creates an autoscaling group. On Tuesday, Bob changes some of the parameters. And then on Wednesday, to see what Bob changes, Alice needs to actually look at the state of the autoscaling group and mentally compare the changes. Now, with CloudFormation, your templates are just text files. So they live in your source control system alongside your code and your Puppet manifests. You get nice diffs to see what is changing, and you can actually consider them as something that can be deployed. One of the reasons I initially fell in love with Puppet was the fact that your server configuration can live in the same GitHub repo as the application code that you're deploying. Now, with CloudFormation, you can also put your whole infrastructure description in the same repository and treat it as one single unit. So for a lot of my client projects, I have a single repository, and that contains Puppet manifest to configure the servers, CloudFormation templates to actually create the resources, and finally the actual code that needs to be run. That's a really simple example, but you can do some pretty cool stuff with CloudFormation. So here is another stack. It's about 250 lines long, so I haven't included the whole thing. The example architecture here contains a DNS name through Route 53, an elastic load balancer, a bunch of instances which are operating across 2 availability zones, and also a database with a hot standby. Now, everything you see in this diagram is in that single CloudFormation stack of around 250 lines. It's not just describing the instances that need to be created. It also sets up the master database with a hot standby ready for failover. It also includes all of your auto-scaling policies, so the policy describing when the web server should be scaled up and down is contained in the same template. Now, a while back, there were a rash of blog posts. It seemed to be a kind of popular meme of blog posts with the title, "If you do X, you're doing it wrong." Now, I absolutely hate the arrogance of these things because X was just the author's favorite way of solving a particular problem. So yeah, I tend to avoid blog posts with that title. Having said that, if you're using AWS in production and you're not using CloudFormation, you might be doing it wrong. So, stepping back from CloudFormation for a moment, Bootstrapping an Infrastructure was a paper published at the LISA 98 sysadmin conference, and they described an almost fully bootstrapped infrastructure. So that meant you configure the first 1 or 2 servers up at the top manually, and then from that point, everything flows from there. Now, this isn't so impressive to anyone now, right? We're all using Puppet, and, yeah. But this is in '98. These guys were building trading floor platforms in the days before Puppet and other tools were so popular. And they were frequently deploying what is essentially the same infrastructure over and over again. And obviously, it's not very cost-effective to be duplicating that work and reinventing the wheel every single time. So this paper was an attempt to capture some of these best practices and make them more reusable. A lot of the tools are outdated. You'll see maybe a reference to CVS in there, but it's still a good paper. And if it was written today, it would be a lot shorter and begin with apt-get install Puppet Master. There is some overlap between CloudFormation and Puppet. So the trifecta that most people start with Puppet is create some files, install some packages, run some services. CloudFormation can do all of this stuff too. So there is quite a lot of overlap. And the downside is everything needs to be embedded in a stack template, which means everything must be JSON encoded. So if you've tried to write long files containing lots of JSON, you know how much of a pain it is to ensure that, yeah, you escape all of your quotes properly and so on. CFN Init is a program released by Amazon, and it brings some of these config management tools into CloudFormation. So a stack has some metadata associated with it, which I'll show you in a moment. The CFN Init program looks at the metadata and then creates files, installs packages, starts servers, and sort of typical Puppety stuff. This works by default with Amazon's Linux AMI, but you can install it on other operating systems. And in fact, Ubuntu has their own version of this, Cloud Init, which does a very similar thing. So let's have a look at an example of CloudFormation creating services and files. I'm sure you can all translate this mentally into the Puppet equivalent. At the top, we have some sources, which are downloaded via HTTP. We say we want to install a Puppet server package via yum, and we say that the Puppet master service should be running. Enabled means the same thing as it does with Puppet. Start the service on boot. You can also use this to run scripts at launch time. Now, you can see the sort of obvious problem with this, which is your script needs to be JSON encoded, which, yeah, is not fun. It's a bit of a pain to write. But what is nice with this is, going back to the bootstrapping and infrastructure thing, you can describe your Puppet master in a CloudFormation stack and have that be completely automated. And then from that point, you can use Puppet traditionally to manage the rest of your infrastructure. How difficult is it to actually deploy this? It's pretty straightforward. Amazon provides the command. You just pass the name of the stack, which is Puppet master, and the path to the template file. I included the URL just for fun. I don't think Amazon understands SEO-optimized URLs for some of their old stuff. When Amazon first launched their tools, they had one package for each particular service. So you had one set of tools for EC2, one for CloudFormation, and so on. What they're doing now with the URL you see in the bottom is presenting a unified interface that works with all AWS services. This is really cool, but it's not quite there yet. I don't think it supports all of the services, or at least it didn't the last time I checked. So I haven't completely switched over to this, but I think given time, this is going to be the way forward using command line tools from AWS. So before moving on, the next slide contains something of a bold statement, and I hope I don't get heckled off stage for it. With autoscaling, you don't know how many instances you have. You don't know what their host names are going to be, which doesn't really fit in with Puppet's paradigm of generating certificates per host and so on. So I tend to just enable auto-sign globally when I'm using Puppet within AWS. Obviously, there are security considerations for this. If you have multiple classes of instances that shouldn't be able to access each other's data, then it's not really for you. But my Puppet masters are behind security groups, so I know that Mr. Joe Public isn't randomly pulling down my configs. As I say, if you have sensitive info, then this approach isn't really for you. I've thought of a few ways to do this, but I haven't had a need to implement it yet. So if you can't use auto-sign, but you need auto-scaling, grab me at the reception or drop me an email or something, and we can talk about some ideas. I'd like someone to be a guinea pig for this. One of the problems with using using Puppet within AWS is the hostname issue. You get an automatically generated hostname based on the internal IP address. There are a few ways to solve this problem. Pinterest have a nice approach. They run a script at boot time, and that connects to a service which is dedicated to generating hostnames. So it knows that it's a web instance, so it asks for a hostname as part of that group. So it will end up with web 001, web 002, and so on. Now, if you only have one type of server in your infrastructure, then you can just use Puppet's default node to apply the configuration. But otherwise, you need a way of assigning roles to instances so Puppet knows which modules should be applied. One thing I do quite regularly here is use the user data to define the role, and then let Puppet read that and configure the instance appropriately. So yeah. When you're creating an instance, you can specify some JSON-encoded user data. Or given that I'm just trying to push everyone towards using CloudFormation, something like this. What you're seeing there in the role web environment staging is JSON inside a JSON file, which, yeah, yo, dog. So this uses a couple of CloudFormation's intrinsic functions, base64. You can guess which encoding method that uses to encode the data. And the join function works the same as similar functions in Ruby and Python and pretty much every other programming language. The reason we need this is because a JSON file, a JSON string cannot stretch over multiple lines, and I hate having massive strings in the text file. So you split it one section per line, and then join them with the intrinsic join function. The Puppet side of this is relatively straightforward. We use standard lib, which contains a parse.json function. Factor makes the user data available to Puppet automatically. So we can just simply run it through the parse.json function, and then we have roles and environment variables which we can use. And if you saw the talk on the roles and profiles pattern, then this fits in with that very nicely. So this sort of gives you a nice way of controlling your configuration from CloudFormation templates. So if you want to control how many unicorn workers, processes you're running, things like that, all of those things can go into the CloudFormation stack and then be passed through to Puppet with user data. The how of configuring your instances is in the Puppet modules, but the what is in CloudFormation. And here we're effectively using EC2 as a very poor man's external node classifier. One downside of this approach is if you wish to change the user data, you need to stop the instance, change the user data, restart it, which is obviously not that nice if you've just got a single web server or something running. Another very useful tool for working with AWS and Puppet is Vagrant. So the first thing I do in pretty much every project I do is start building Vagrant boxes, so I can get sort of 90% of the way there before I even launch an EC2 instance. I mean, I'm building these things on my client's AWS infrastructure, so I'm not paying the bill, but it's still nice to try and keep it as low as possible, at least during development. The nice thing about Vagrant is it obviously reduces the iteration time for creating new instances, testing changes, and so on. So if you're building things directly on EC2, you make a mistake, you need to terminate the instance, wait, launch another one. It's just a lot quicker to do Vagrant destroy, Vagrant up, you're done. Of course, there is the Vagrant AWS plugin, which you can use, and that's going to bring up the instances in AWS, but still give you the flexibility of just saying, destroy it, rebuild it, done. So first we start in local dev, which is my laptop here. And once everything's working to a certain extent, we go into the staging environments, and then finally into production, where we actually have a serious number of instances running the code. To reuse the same pattern, we can provide essentially fake user data using Vagrant. So in your Vagrant configuration file, you can specify particular facts that are passed on to to Puppet. And we can just replicate the same structure here of passing some JSON and then letting Puppet parse that. So the advantage here is you're using the exact same flow in development, staging, and production, and you don't have to have little, if local development is true, then blah, blah, blah. Many of the AWS services are based on open source products. So Elasticache is equivalent to Memcached, RDS can use a MySQL backend, and so on. So what you can do is have a switch in your Puppet config to say, depending on the environment, you can either use Memcached on the local host or Elasticache from EC2. The great thing about this is it's reliable, repeatable, and it gives you a very nice progression to go from dev, staging, into production. I'd like to take a moment to talk about decoupling, which is the key to any successful AWS deployment at scale. So what does this mean? Here's an example application which acts as an image resizing app. So user would upload an image to the web server, and then some EC2 instances would be responsible for actually resizing the images, adding watermarks, or any of those sorts of things. Now, the web server never talks directly to the instances that are processing the images. Instead, it sends writes a request to the queue. That queue is read by the photo processing instances, and then when they finish, they write a message to another queue saying, yep, I'm done, here's the URL of the resized images, and so on. So again, there's no direct communication between the web server and the processing instances. This means you can scale the services completely independently. So if you suddenly decide that you need ultra-high quality images, you can change that, and your web instances are going to have no idea and not even care that things have changed on the back end. They just need to keep writing to the same queue and reading the results. The really nice thing here is, let's say someone deploys some broken code and kills your whole photo processing cluster. Your users will effectively never know, because the web server is going to accept the instances, and then they're just going to sit in the queue until some instances come back up and begin processing that queue again. So by separating these components, you can isolate failures and hopefully avoid those situations where one thing breaks and it flows up, and then you're left with a completely dead site. Decoupling is one of the benefits of the service-oriented architecture pattern, which is where each component in the app is a separate service, and all communication is done via APIs or perhaps by a queuing system. For this example, the queuing system is Amazon's SQS, so as long as you pay your bill, just keep on throwing images at it, and you don't need to worry about scaling that part of the application. If the image processing is not time sensitive, then your scaling ceiling is how many messages you can store in SQS. If they need to be processed within a certain time frame, then it's a factor of how long it takes to resize each image and how many instances you have processing the queue. So the main selling point of AWS services like RDS and SQS is you move the scaling problem to Amazon. So for every component in the infrastructure, you need to ask yourself, what is the scaling ceiling? Where is the next bottleneck going to be? And if you're using SQS as your queuing system, then you have two limits, which is the built-in Amazon strict limit of how many messages you can put in a queue, and your budget, how much you want to pay Amazon. And 99% of the time, you're going to hit your budget limit way before you hit any of Amazon's limits. So what does this actually have to do with Puppet? With a Puppet master and autoscaling, your scaling ceiling is a factor of how long it takes to compile and apply catalogs and how many instances you launch simultaneously. So with autoscaling, you might launch 10, 50, or 100 instances, and they're all going to hit Puppet at the same time and ask for a catalog compilation and then apply the nodes and so on. This essentially makes Puppet a single point of failure because if the instance can't be provisioned by Puppet on boot, it's never going to enter service, and it's effectively a useless instance. So this means if your Puppet master is broken, autoscaling is broken. You can scale Puppet master, and you can make a redundant cluster from it. I think GitHub at the last PuppetConf gave some really nice talks on how they're scaling and clustering Puppet. But I'm a lazy sysadmin, so if I can just avoid having to solve a particular problem, then I will. It means you can effectively sidestep the issue of scaling your Puppet server and have one less moving part in the infrastructure. So when my instances boot, they typically pull the latest version of the application code from GitHub or a central repository or so on. So why not pull the Puppet manifests at the same time and then apply them locally with Puppet apply? Then you don't need a Puppet master anymore. So it's a really super simple version. When the instance boots, you run the magic update.sh script and then apply Puppet locally. So you've cut out one moving part, but you also lose a few things. Your scaling ceiling, once you've removed the Puppet master, is how many instances can simultaneously pull code from the deploy system. And if you're using something like S3, this limit is pretty high. And again, you're going to hit budget constraints of how many instances you can run before you start hitting the limits of how many files you can pull from S3. As I said, you do lose a few things. Puppet dashboard, which is nice and getting even nicer by the day. Exported resources, stored configs. Obviously, each machine is isolated. There's no Puppet master, so there's no way to configure a machine dynamically based on the prior Puppet runs, data that was received that way, and so on. So there is something of a trade-off here. You do lose a few features, but you remove one of your scaling worries. Now, if you don't have a Puppet master, you can't really have your instances trigger Puppet runs or have them run every 30 minutes in the traditional way. So one thing we can do here is actually trigger the Puppet run with Fabric. And I'm using Fabric just as an example. There are a million other tools that will do this, including Bash and SSH. So Fabric lets you define role definitions, and these are groups of instances. Now you can see I've hard-coded www1 through 3, and that's obviously not going to work in AWS. But for the sake of example, we have a run Puppet task, which will simply run Puppet locally on the instance. The @roles decorator, if you're not familiar with Python, a decorator is a way of applying a set of code to a function and so on. So the roles decorator says that the run Puppet task should be run on the DB and web instances. The bottom two examples are just two different ways we can do this. So the first one, fab run Puppet, that will look at the roles decorator, see that Puppet should be run on DB and web, and then run it on all of those instances. The bottom option is how you could run Puppet just on your DB roles. So obviously this is pretty useless in AWS, as your host names are not going to be ww1, db1, and so on. So I made a little helper. It's on my GitHub account, which will dynamically set the roles based on the tags that have been assigned to an instance. So there's some overlap between user data and tags. The key distinction is that user data can be retrieved from the instance just by hitting a URL with curl, whereas tags need access to the Amazon API. So it means obviously you have to provide some credentials which have permissions to list all of the tags, describe instances, and so on. So one pattern I tend to use here is to duplicate the tags and the user data. So just set them to exactly the same thing, whereas the user data is a JSON string. Tags are actually key value pairs. So as long as they match, it's OK. The role definition in Fabric can actually be a function. So if you specify configure roles, then that function will be called every time Fabric needs to look up the role definition. So what we do here is get a list of all instances which are tagged with role equals DB or role equals web. So when this returns, you have a dictionary containing all of your roles based on the tags you've assigned through the AWS Web Console or CloudFormation. This is quite nice in some ways, as you can trigger Puppet runs selectively. And a lot of the time, if you say you're removing an SSH key or something, you want to run everywhere. But there are cases where it's useful to just run Puppet on a subset of your infrastructure. And what's nice is this can all be hooked up to Jenkins, so you can push out Puppet changes in the same way you push out changes to your application code. Now, I have to confess, I wasn't sure if I would have time to talk about this, so I haven't included a slide for this. But something I've been doing lately is using Jenkins to build Amazon AMIs. What a lot of people do is use the AMI as a unit of deployment. So if you want to push out a new version of the code, then instead of actually updating a running instance, you build a completely new AMI. The downside of this is building AMIs manually is slow, boring, tedious. But that's what Jenkins is for, right? So using Jenkins and Vagrant, they've come up with a nice flow for automatically creating the AMIs. Now, the flow is essentially a three-part job in Jenkins, where Jenkins will use the Vagrant AWS plugin to launch an instance and provision it with Puppet. And obviously, if the provisioning fails at any point, then Jenkins recognizes this and notifies you that the build has failed and doesn't continue. Assuming the instance gets provisioned correctly, then in theory, you have an instance that should be ready to work. So you can create an AMI from that. I've written a plugin for Vagrant called Vagrant AMI, which is only going to be useful for like another month or so, if it's not already superseded. Mitchell, the author of Vagrant, has created a new package called Packer, and its sole purpose is to create images in AWS or VMware and so on. But currently, Packer doesn't have the same level of support for provisioners that Vagrant enjoys. And I needed a way of creating AMIs very quickly from running instances that have been provisioned by Puppet. So the idea is once the instance has been fully provisioned, you run the Vagrant AMI plugin to create the AMI. That all happens automatically, and the resulting AMI ID is passed back to Jenkins, so you have a record of that. The next step in the build process is to launch a CloudFormation stack containing your new instance. So with CloudFormation, you can provide parameters, input parameters, which let you set a variable as you're creating the stack. So we create the CloudFormation stack from Jenkins and pass in the ID of the new AMI. That launches the new stack, and after a few minutes, you've got your stack up and running. The reason for doing this is that it gives you a better way of testing the AMI. Just knowing that it's been provisioned OK is not always good enough to know that it's going to work with autoscaling and know that it comes up correctly. So by actually testing it with CloudFormation stack, you can make it a much more realistic test. So if you have a web server, you can put that behind an elastic load balancer. And then from Jenkins, you can run your functional tests against the load balancer. and verify that your new web AMI is functioning exactly as it's supposed to. And only once the functional tests have passed is the AMI marked as a success. That's done using the promoted builds plugin, which is quite nice. It lets you hook back a few levels up in Jenkins' job to say whether a build failed or succeeded. So with this flow, we have a way of automatically creating AMIs, running functional tests on them, and then having a job finish and say, OK, I'm all done. Here's the AMI ID of your new AMI. And you can then make a little change to your CloudFormation stack, push the changes, and you've got that out into production. And if you ever need to go back, then you've still got your old AMIs there that you can return to. It's not just the developers that get to use Vagrant anymore, Jenkins anymore, right? Right, I'm getting close to time. So, thank you everyone for listening. Does anyone have any questions? Cool. Would you mind coming to the mic?
Do you mind repeating my questions?
Sure.
How long does it take you to build the AMIs?
It depends. The question was, how long does it take to build the AMIs? And that is a factor of how complicated they are, how much stuff you need to do with Puppet. So to give you an example, I recently set up an AMI which is just acting as a very basic Nginx load balancer. And that takes about 10, 15 minutes or so to go through the process of launching the initial machine, provisioning it, creating the AMI. And then it's still going to be another 10 minutes or so for launching it in CloudFormation. So yeah, it's not the quickest process, but what's nice is you click a button and then go and have coffee.
Related to that,
Yeah.
why would you have used an EC2 instance for that load balancer rather than using just DLB or something?
A couple of reasons. So ELBs are good, right? They're nice, but they have some really strong limitations, in my opinion. An instance is either behind an ELB or it's not. There's no concept of draining. So as soon as you remove an instance from an ELB, it terminates any existing connections and returns 500, which is pretty nasty. So for this particular client project, there are actually 3 separate autoscaling groups behind this Nginx load balancer. And if you are just using the ELB, then it becomes quite difficult to remove instances cleanly. There's no way to effectively say, finish what you're currently doing, but don't accept any more connections. Which is why I get happy whenever I'm using Rackspace's load balancers. Right-click, drain connections, done. Any other questions?
I was curious if you had played with mCollective as an alternative for Fabric. I personally really like Fabric, but mCollective was a huge setup, but it seemed like it might do a lot of the same things. And even in your, I was curious if you would use that, or if it could even be possible to use that in a only run Puppet locally, don't have a Puppet master kind of scenario.
That's a good question. I have to admit, I don't know mCollective well enough to say whether or not. I imagine it could be. And yeah, Fabric is a personal preference. There are many ways to skin this particular cat.
So you mentioned building your own images, and it sounds like you're building them by capturing them from EC2, but you also mentioned Rackspace. So do you do something similar in that environment, and how do you kind of reconcile the differences between the, between the images?
I've not had a cause to use that with Rackspace yet, but I mean, Rackspace does have their API for launching instances and so on. So I'm not sure if there is a Vagrant plugin for Rackspace, then you can just effectively copy the procedure and work it there.
I asked earlier with the Google guys. Just curious how you're handling clients that need shared disk access, which is to say POSIX access, between, say, webheads or app servers or something like that.
I'm sorry, could you say
shared?
that, please?
I'm sorry, shared POSIX access between app servers or autoscaling groups.
I'm not quite sure what you mean.
Have an application needs to go ahead and write to disk, which is to say shared disk use between the app servers in a
Yeah.
POSIX fashion.
Oh, right, so network shares, essentially.
Network share, but how do you go ahead and supply the actual share? Where are you running the share from is the real trick.
Okay, so
I've
this
heard
isn't...
Gluster, I've heard Ceph. I've not found a really good answer that had relatively good performance yet.
I'm afraid you're not going to hear one today either.
That's what I was afraid of. Okay.
I think it's an interesting one. Grab me afterwards, we can talk about some ideas.
Sure.
Hi.
Do you have any thoughts on OpsWorks and how that fits into the ecosystem and benefits versus?
Yes, I do. The question was thoughts on OpsWorks. So I was going to have like an elephant in the room slide and talk a little bit about OpsWorks. Yeah. Frankly, I think focusing so strongly on Chef was not the best idea. But OpsWorks came out of an external company, I believe, and then Amazon bought them. So it's necessarily that Amazon decided to do that. What I would have loved to see is something like they've done with RDS, right? So you launch a database and you choose Oracle or MySQL. I would have loved to see that with OpsWorks. Yeah, choose Chef, Puppet, Salt, or whatever. I don't know if you saw the demo from the Scalar guys who are presenting here. Have a look at that. That is very cool, and it knocks the pants off of OpsWorks, in my opinion, and works with pretty much everything. I should have signed up for like an affiliate recommendation thing before coming out here.
Can I ask a question?
Yeah, sure.
A little blocked in.
Yeah, go for it.
I've noticed at the conference the notion of a proxy Puppet server, an agent that would basically be a proxy to create Amazon instances
Yeah.
as a new provider or resource.
Mhm.
Do you have any thoughts of using that versus CloudFormation? If that could be improved and expanded and perfected, would that replace CloudFormation?
I think it will go some way towards that. But given the speed that Amazon moves and adds new services and so on, I think it is going to be running behind for a little while. But yeah, I mean, if you're using, especially if you're using a hybrid environment, right? So you've already got your Puppet master running somewhere, then yeah, that is going to be a very nice solution. And once all of this can just be wrapped up within a single set of Puppet modules, I'm going to be a very happy man. Anybody else? Would you mind coming to the mic, please? Sorry, they made me promise to ask.
I was wondering if there were any Puppet modules you'd recommend for extending the DSL to cover some Amazon resources. So I'm spinning up a lot of instances where I need elastic IP addresses or I need EBS volumes, and describing them in CloudFormation kind of defeats the purpose. I kind of want them to come up and I want to be able to describe what these hosts should look like. And I can do it for all kinds of resources, but I can't do it for the Amazon-based ones.
Okay, I think that ties into the question that the gentleman there just asked, which is, yeah, Puppet is doing a lot of work in this area, and I'm not, I'm a Puppet user. Like, I'm not a developer. I haven't looked into adding too many things directly into Puppet. But yeah, I think the new AWS resource types are going to solve a lot of those problems for you. All right, I think that is me done. Thank you, everyone. Can I take the laptop off? It was perfect.